thought I'd do some um, coordinate geometry proofs for you in regards to at least triangles. Uh, Varying types of questions, but they may ask, can you describe what kind of triangle this is in regards to the number of sides that are congruent? So is it scalene, isosceles, equilateral? Then they might ask, is it a right scalene? Is it a right isosceles? Um, so a couple things that we're going to look at here are the distance formula and the slope formulas. The distance formula, again, from class, we know to be d is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. And the x2, y2, and x1, y1, those come from your ordered pairs here. So if I'm going to look at, for instance, finding the distance of these three segments, I'll find distance of A to B. So what we have over here are these two ordered pairs, where one of those is x1, y1, one of them is x2, y2. I don't really care which one's which, but basically what it tells you here with the formula is subtract your x's. And like I said, I don't care which is which, so it doesn't really matter the order that I subtract them. So I'm going to go 9 minus 4. That gives me 5. So x2 minus x1 is 5. We'll square that and get 25. Then I'm going to subtract the y's. So I get, again, order doesn't matter. So 4 minus negative 1. Okay, so 4 minus negative 1. That gives me 5. I'll square that and get 25 as well. So I add those two things together, and it's going to give me a result of radical 50. And that is then the distance from A to B. We're also going to want to know what is the distance from maybe B to C. Alright, so now we're going to be looking at these two ordered pairs. And again, I'm going to subtract the x's, so 9 minus 8, maybe in this case, gets you 1, square that, you get 1. I'm going to add to that, subtract my y's, so 4 minus negative 5 is 9, square that, you get 81. So that gives me a total of root 82. Next thing I'm going to try to do is find the length of the remaining segment. So I've done AB, I've done BC, and now I need to do AC. So distance AC. And so now we're looking at that point and that point. So again, subtract your x's. So 8 minus 4 gives you 4. Square that, you get 16. Add to that. Now subtract your x's, or sorry, your y's. Negative 5 minus negative 1. So that's going to give me negative 5 minus negative 1 gives me negative 4. Square that, and I get 16 again. So I get root 32. As we're doing this subtraction, again, it doesn't matter the order that I do it, because we do know that subtraction is not commutative, which means that when I do that subtraction there with the x's, or I do the subtraction with the y's, it does matter that order. For instance, if I would have done negative 5 minus negative 1, I do get negative 4. But if I would have done negative 1 minus negative 5, that would give me positive 4. So the order does matter, because I'm going to get a positive number or a negative number, and I should be worried about which one of those I get. However, because we're going to square things, a negative 4 squared is positive 16. A positive 4 squared is, again, positive 16. So ultimately, it doesn't matter the order that I do the subtraction, because when I square it, it's going to take those numbers, whether they're negative, and it's going to make them positive, or if they were positive, they're going to stay positive. So as I go through this, again, I know my distances. We're going to use GeoGebra here in a little bit to kind of verify those distances. But the next thing I want to do, obviously these distances are all different, so the geometry tells me that this shape is going to be scalene. Okay, the triangle is scalene. But now I want to see if there's any right angles. So the way I find right angles is I'm going to find the slope of all these lines. So slope of AB, we'll find the slope of BC, and then we'll find the slope of AC. So we'll find those three slopes. The one thing you got to remember, and this is probably the most important thing you took from Algebra 1 last year, is that the slope of a line is equal to, we've called it in class maybe delta y over delta x. Delta meaning change in. So when we talk about change algebraically, it means subtraction. So we're going to subtract two y values, y2, y1, and subtract then two x values. And again, it doesn't matter the order that I subtract them, because obviously the problem doesn't know if I'm going to find a slope of a to b. It doesn't know if I've gone from a to b or if I'm going from b to a. However, what is important is how the order that I subtract my y's is going to dictate the way I subtract my x's. I need to understand that I'm going to be pairing things up correctly. If I'm going to subtract y2 minus y1, then the first thing I subtract in the bottom has to be x2. These subscripts have to match. So just be careful with that. That is something that people don't pay attention to, and if you don't pay attention to it, you're going to get the right numerical quantities, but your signs are going to be backwards. All right? If you're supposed to get a negative sign, you'll end up with a positive, and vice versa. So if I want to find the slope of a to b, all right, so I'm going to use these 2 points. And like I said, it doesn't matter. I'm going to go, let's let this one be x2 and this one be y2. So then I'm going to go 4 minus negative 1. So 4 minus negative 1. If that's x2, y2, this one's going to be obviously your x1, y1. So 4 minus negative 1. And then because I started with this 4, started with that ordered pair, and the bottom I'm going to start with this ordered pair. So 9 minus 4. So what I end up with there is 4 minus negative 1 gives me positive 5. And then 9 minus 4 gives me 5 as well. So my slope here, 5 over 5 reduces to 1 over 1. When I want to do the slope of BC, I'm going to do the same thing, but now I'm going to be focused on these 2 points. So again, subtract my y, so I go 4 minus negative 5, and then we'll subtract my x's, so I go 8, oh sorry, not 8, I go 9 minus 8. 9 minus 8, make sure you got the right order. So up top, that's going to give me 4 minus negative 5 is 9. On the bottom, I get 1. So my slope there is 9 over 1. Now when I do C, okay, or sorry, AC, I'm going to be using that ordered pair and that ordered pair. So then again, subtract your x's, subtract your y's, put your y's on top. So I'm going to go y2 minus y1. So I'll go negative 1 minus negative 5. Negative 1 minus the negative 5. And then on the bottom I go 4 minus 8. So when I do that, I get negative 1 plus 5, so it gives me 4. On the bottom I get 4 minus 8, which gives me negative 4. So it gives me negative 1 over 1 when we reduce that. So those are our 3 slopes. And when we determine if these 3 slopes, any of them are perpendicular, or come from lines that are perpendicular. Remember, slope is a characteristic of a line. Slopes can't be perpendicular, but the lines are the things that are perpendicular. But the relationship between slopes is what's going to tell us, are these 2 line segments forming right angles? And the way we do that is we look at the slopes, and we start comparing 2 slopes to one another and see, are they opposite sign reciprocals? So if I look at these 2 right away, they are not reciprocals. So those 2, if I look at those, because the names share B, I'd be looking at trying to prove that angle B is a right angle. And because those are not opposite sign reciprocals, we're able to see that they are in fact not right angles, or not providing a right angle. So then maybe I look at maybe those 2. So now I'd be looking at BC and AC. Well, BC and AC share point C, so we'd be trying to figure out, in this case, if this angle down here is in fact a right angle. And again, they are not opposite side reciprocals. So angle C is not a right angle. However, the last comparison that we need to make would be that one there to that one there. And if we look at those two, -1/1 and +1/1, they're opposite signs, and they are also reciprocals. Now, they're kind of boring reciprocals, but they are still reciprocals. So that tells me, because that segment and that segment both share point A, then we have just shown that at A, because we have opposite sign reciprocals, there should be a right angle. So what we can do, because this is scalene, but now we have a right angle here, we can identify this triangle ABC, as a right scalene triangle. And that's a coordinate geometry proof. We have shown with valid arguments that is how we can define that shape. What I like about doing this in GeoGebra is that we can kind of quickly verify these things. So we could ask it to find distances. So once I click that distance tool, I come down here, click that segment at 7.07, that segment's 9.06, and that one's 5.66. Now, none of that stuff matches up with what we found over here with the radicals, but we can type in at the bottom in the input, we go square root SQRT, and then I'm going to type in 50. So I'd be finding length of AB, and GeoGebra says AB should be 7.07. Hit enter, and then you see that this number right here is 7.07. So that is the square root of 50. Okay, I'm going to find then the square root of 82, which should be, that's segment AB. So GeoGebra is saying A to B. What did I just? I'm sorry. A to B. Oh no, sorry. B to C. B to C is the radical 82. So B to C is this. What ultimately turns out to be our hypotenuse. Type that in. It should be 9.06. Hit enter. It gives me 9.06. So square root 82 is that number right there. And then the last one, same idea. Type in root 32, and that should give me 5.66, and it does. And that's a validation that we are doing things correctly here. So that's nice with the distances. The other thing is that we can actually click on the distance tool and go to angle. And now I'm going to ask this thing to find the angle right here at A, and hopefully prove to us that this is a right triangle. Just clean things up a little bit here. If I do this, it does show me that that's 90 degrees. Okay, so again, a visual proof, algebraic proof that our work that we did was correct. Other things you could have done, this measurement tool here allows us to do slope. So I could have clicked, once I click slope, you see here it says select line. So I'll just select a line, and that one gives me the slope. I know it's, sometimes you gotta move these things around, but it says the slope there is 1. Now it's not really nice and neat to see that, but what GeoGebra is doing is saying that that segment is actually a portion of that line right there, and that line has slope 1. So that's why that little triangle that's showing you rise or run is outside the triangle. I could then do slope again for this here, and we see, move this thing a little bit, you see the slope was 9, which is what we found algebraically, and then the final slope is over here, which would be hopefully -1, and that's what we're seeing right there. So validation that everything we did by hand is appropriate. All right, I'm going to go through this one. Might go through this one a little bit quicker than the last one we did, since we kind of already talked about all the concepts. I'll just kind of get that practice and keep the more of these, obviously, we talk about and discuss and practice, the better we're going to get. So again, trying to name this thing. I look at this and I think probably going to be isosceles, but we, again, making that argument and um, making that distinction is not good enough by just saying looks, because, you know, that might look isosceles to some of us too. That might, that might, that might. Okay, so with the naked eye, some of this stuff is questionable. So using our algebra tools, we should be able to convince ourselves that in fact this is isosceles. So again, distance formula. We're going to go x2 minus x1, that quantity squared, plus then y2 minus y1, that quantity squared. I'm going to find distance a to b. So a to b, again, using those two things there. Okay. Subtract your x's, so that gives you 10. Square that, gets you 100. Well, then you're going to add to that the difference in your y's. Subtract those, you get 2. Square that, you get 4. So the distance between a and b is square root of 104. Now I'm going to do the distance for a to c. And these distances, they're all independent of one another, so it doesn't matter the order that you do them. Looking at a and that point c, so I'm going to subtract the x's. So 6 minus 4 gives me 2. Square that, you get 4. And I'm going to subtract my my y's, and I get 16. The square root of 16 is 256. Or sorry, the square of 16 is 256. Add those together, I get root 260. Okay. And then the last one we want to do is the distance from b to c. So again, now we're going to look at these two ordered pairs. So when I add those together, add those differences together, I'm going to take the x's and subtract those, so it gives me 8. Okay, 8 squared is 64. And then when I take these and subtract those, I get 18 and 4, so that gives me 14. The square of 14 is 196. Okay, so adding those together, this 4 will make that a 200. 200 plus 60 then is 260. So right there we see two distances that are the same, so, and one that's different. Okay, this 104 is different. So that means that this triangle is isosceles. And now we got to figure out, are there any right angles? Okay, so my hope for you to realize here, what we've just figured out is that that distance right there and that distance are the same. Okay, when we dealt with the scalene triangle, we had to basically find all the slopes, because we didn't know necessarily the potential of where that right angle could show up. But we have some algebra here that tells us that if we know that those two, or sorry, geometry, there's some geometry that shows us that if we know that those two distances are the same, by the isosceles triangle theorem, that angle and that angle both have to be the same. So if they're both the same, that means this angle cannot equal 90 degrees, and this one cannot equal 90 degrees either, because you can't have two 90-degree angles in the same triangle. So by that recognition, by knowing that those two angles have to be congruent, this is the only one up here that could potentially be a 90-degree angle. Meaning then, all we have to find is the slope of A to C, the slope of A to C, and the slope of B to C. We don't have to worry about A to B slope. Okay. You could, obviously blindly approach this, find all three slopes, and come to the same conclusion. But I think knowing that, using that logic, makes things a little bit easier. And that's kind of the intent of this course, is to learn these properties to make your work a little bit more efficient, to be able to recognize certain properties, allow me to not have to pay attention to certain distances, certain quantities, certain slopes, because they do not impact the problem the way that we think they might somewhere else. So when we find this slope of a to c, I'm going to look at, again, these ordered pairs, and again, slope is y2 minus y1 on top. So I'm going to go 18 minus 2, and then x2 minus x1 on the bottom, so I have 6 minus 4, and that 18 minus 2 is 16, and then 6 minus 4 is 2, so it gives me a slope of 8 over 1. Okay. Now I'm going to find the slope of b to c, so we're looking at those two. So again, subtract my y's on top, so 18 minus 4 gives me 14. And then on the bottom, I'm going to subtract those as well. So I went 18 minus 4, so I go 6 minus 14. 6 minus 14 is negative 8. Okay, so when I look at that one, I'm looking at a slope that is, those reduced, 2 goes into both those, so 7 over negative 4. Okay, did I do that math right? 18, 4, 6, and 14, that's 8, yep. Alright, so those two slopes obviously are not opposite sign reciprocals. We can look at some stuff here to verify that we've done things correctly. If I look at this one, gives me my slope. Let's see if we can drag this down. Gives me that slope to be 8. Okay, now if I look at the slope over here, it gives me negative 1.75. And just to see it, that is the same thing as 7 and negative, or divided by negative 4. If you type in negative 7 divided by 4, it'll actually calculate that, and you do get that negative 1.75 that slope is saying for that line segment right there. So they're not opposite sign reciprocals, therefore this angle C is not a right angle. Okay, not a right angle there. And again, we come back here and clean things up here a little bit. We could ask it to find that angle measurement. Did it backwards. So we want to go find the angle measurement between, I guess we have to go A to C to B. So A to C to B, and it gives me that angle measurement there to be 36.87. Obviously, not 90 degrees. So all we can do is name this thing as isosceles. Okay. So hopefully that's some examples that might help you through some of these coordinate geometry proofs. We're going to continue to use these things all the time, but we'll build on it, and eventually in other chapters talk about different types of shapes instead of just triangles.